So this is a really nice little algorithm, completing the square. Do you remember completing the square from grade 10? Like maybe you couldn't do it on your own, but you remember talking about it at least. So yeah, it's a nice little trick. It's very useful. Remember when we were graphing last week, and there's a certain form that we have to have our equation in order to graph, right? So that you can find the a, the h, and the k. So you can figure out those transformations. And that's what completing the square does. It puts it in that form. So I take something that's not in that form, and I can put it in that form. And that lets us solve a whole bunch of questions. So it's a really nice little trick because it always works. It's not like factoring where you got to figure out what the factors are. With completing the square, you make it happen. You make it work. So it's a neat little trick that way. And but it does rely a little bit on factoring. So we're going to just quickly review this. Remember when you expand something like this, x plus 4 all squared, what would that look like? That would look like this. Right? And that would look like, that's going to turn out to be x times x, so x squared, x times 4, 4x, 4 times x, 4x, and then 4 times 4, which is 16, but I'm going to write it right now as 4 times 4. Okay? Zoom in a little bit. And that means I get x squared plus 4 is 8, and 4 times 4 is 16. So these two add to the middle term, and the same two multiply to the last term, like the 4 and the 4. This is the shortcut to expanding them, is I know the middle term will be 4 plus 4, and I know the last term will be 4 times 4. Okay? It's really important that we understand that pattern, because that's what lets us do this trick. So if I'm factoring, what two numbers add to 10 and multiply to 25? And they got to be the same numbers. 5 and 5, right? So this is x squared plus 5x plus 5x plus 5 times 5. If I'm going backwards, right? Which we don't really write it this way, but it ends up being x plus 5 times x plus 5, which is x plus 5 all squared. So again, we're not factoring today. We will factor in the next unit. We'll do more factoring. We're not really factoring today, but we're using this idea of how this is called a perfect square trinomial. Okay, so when I can write it like a binomial squared. And you might recognize that because the equations that we were looking at last week were things like this. 2x minus 3 squared plus 4. So in that equation, when we've got the a, the h, and the k, and we can graph it, I've got that binomial squared. In this case, x minus 3 squared, right? And so that's what we have to make that happen. That's what completing the square does. That makes sense? Kind of remember this? Tricky for like a, I know it's not Monday, but it's like a Monday morning. Is this too much thinking for a Monday morning, or are people okay with this? Too much thinking? It's really important that you think about that relationship and that we get that. Okay? Okay. So I'm going to write this down. If you don't love it with the A's and B's, if you like thinking about it with the numbers, that's fine. But this is like the general version. So a plus b all squared gives me a plus b times a plus b. Remember, I multiply. It's not a squared plus b squared, right? That's not what it is. So this is a squared plus ab plus ab plus b squared, which is a squared plus 2ab plus b squared. And a minus b a squared minus AB plus b squared. So it's a squared minus 2ab plus b squared. These, like, you could think of these as like formulas. We don't really use them that way. Like sometimes we do, but we're not going to today. But that's what you could think of those as. And that means that when I have this situation, a squared plus 2ab plus b squared, I can write it as a plus b squared. Or if the middle term is negative, it's a minus b squared. And that's the important relationship that we need. Remember, if you didn't like that with the a's and b's, that's fine, because we're going to be doing it with numbers anyway. So you're going to be given an expression that isn't a perfect square trinomial. And we have to turn it into one. We have to turn it into this kind of relationship where the same number, 5 plus 5, gives me 10, and 5 times 5 gives me 25. So we're looking for those numbers. So when we go down to this question here, what's the value of C that would turn this into a perfect square trinomial? So that the same number adds to itself to give me the 8 and then multiplies itself to give me some other value. Understand what this is asking? Does anybody think they know what number it is? 4. So 4 is the number that 4 plus 4 is 8. Very good. So my C value is going to be 16 because we take that and square it. So C is 16 because it's equal to 4 squared, because 4 plus 4 is 8, right? And that's kind of where we came up with 4. And you could also think of that as 8 divided by 2. So I take that middle term. Like if you want the formula for how to do it every time, you take that middle term, divide it by 2, and square it. And that's our C value. So what's it going to be for the next one? 25. Take 10, divide it by 2, which is 5, and negative 10 it's still going to be positive when I square it. So I take that term, divide it in 2, cut it in half, and square it. What about the next one? Oh, wait, before we, no, we'll do it this time. We'll do it on this one. So what about this one? So I take 16 and divide it by 2, which is 8, and 8 squared is 64. So what that means is x squared plus 16x plus 64 is a perfect square trinomial, and I can factor it to look like this. In fact, if I go back and I include that step, 16 divided by 2 is 8. So the next important part of this process, once we start actually completing the square, is that number there is the one that I get in my brackets in the second step. That's not what we're doing yet because we're just finding out this value of C. But the next step is going to be to write it like this, and that's the number there that we need. Okay, so one more. Hopefully we're getting used to this pattern now. So I take negative 34 and divide it by 2, which is negative 17 squared. And what is negative 17 squared? Somebody with a calculator? $289. Okay, nice. And that means that it's x squared minus 34x plus 289, which equals x minus 17 squared. That's the number that goes there. Good? It seems a little strange to do this until we start doing it, but I know you've seen this before, so maybe you kind of know what's coming. But it seems at first, when you first learn that, it seems strange because we're just kind of messing around, goofing around. But when you put it into action, then it makes a lot of sense why we're doing this. If you like formal instructions, there you go. There's a 7-step process for exactly how to complete the square. We're doing 2 days on this, so today we're doing the easier ones. Tomorrow they get a little bit harder. And some of the steps are really small, and it's not actually 7 steps of writing. We're going to show a couple of extra steps to start, but then by the end, when you're getting really good at this, you can probably do it, I would say, safely in 3 steps. Okay, it's typically how we do it. But I will point out which step is which at least a little bit as we go. And if you, like I said, if you like those kinds of formal instructions, you can go back and use those to help you if you ever get stuck. Okay, so let's get into this. Here is an example of a quadratic relationship like that you could graph. That would make a parabola, except we don't know how to graph this because it's not in the right form. X squared plus 12x minus 3. I could use technology to graph it, but graphing it like this, we don't know how to do that. So if we complete the square, it puts it in the right form that we can graph it. So the first thing is, if it's not fully simplified, then you simplify it. This one already is, so step 1 is done for us. Step 2 is group the x squared and the x term together. We don't usually do a whole step like that where we write it that way, but this time we are. But what you're going to do is you're going to just consider the x squared and the x term. And the constant, in this case, that minus 3, the negative 3, we're just going to ignore it for now. Now this is where I find that value c that we were just practicing. So what would it be for this one? If I just ignore everything else and I just look at the x squared plus 12x, what would my c value be? 6. So 6 squared is 36. Very good. So I take that 36 and I add it and I subtract it. Why do we do that? Look, it says right here. Find the value that turns what you have inside the brackets into a perfect square trinomial. Add and subtract that value. Why do we do that? Yeah, because if I add it and subtract, it seems like it's such a strange thing to do, but there's a neat little trick. I'm effectively adding 0. Right? So I haven't changed the equation, but we're doing it in this convenient way. Okay, so now I take the negative 1, and tomorrow it's going to be a little bit trickier, but for today, I just take it and stick it outside the brackets. But tomorrow, when we do the ones that are a bit harder, you have to do something to that number when you put it outside the brackets. That's why even today, we're starting with it in the brackets. Some people would want to skip that step because they're like, oh, why do I have to write, like, I've basically written the same thing twice. But it's because tomorrow it gets a little bit harder, and so you want to get used to writing it like this. Okay? And then what I have left in the brackets is that perfect square trinomial that we created. Right? We designed it to make sure that it would work like this. And there's that 6, half of the 12x term. And then negative 36 minus 3 is negative 39. And now if I wanted to graph this, I've got my a, it's 1. I've got my h, it's negative 6. And I've got my k, it's negative 39. That'd be hard to graph because negative 39 would be kind of tricky, right? But what do you think? Does that make sense? It's the exact same process every single time. That's what's so nice about this. It's so useful, but it's also so straightforward. It's, like I said, it's not like factoring where, you know, every question's a bit different and you got to try to figure out the numbers. Okay, so we're going to streamline this process a little bit, but we're going to, but like not yet. We're still going to kind of do it the long way. So I take the x squared and the x term, and I just think about them on their own. I take half of the x term, which is 2. I square it, so 2 squared is 4. And I add it and subtract it. So 4 is the number we want. So plus 4 minus 4. The plus 1 is still outside. I take the negative 1. You always take the negative 1. Leave the positive 1 inside the bracket. Take the negative 1 outside the bracket. And then write it in the proper form with that middle term factored. So what's going to be, and you always, see, you have to know that this is what you're trying to get it to look like. Y equals the brackets with something in it, obviously, squared, and then plus or minus something on the outside of the brackets. We have to recognize, this is called vertex form, or that's one of the names that we use to describe it, because it gives us the vertex and it's easy to graph with. We have to know that that's what completing a square does, is it's getting us this. So what do I put inside the brackets here? 2x. And what's the rest of it?
X or negative 2.
Yeah, x minus 2. Very good. Right? So it always shares the sign as that middle term. Any questions before we're going to just do a bunch more examples here? Or actually, not a bunch more. We're only going to do one more. Well, 2 more, sort of. All right, let's try it. So y equals, this time I'm not going to write that first step. I'm going to go like this, plus 8x, and then I'm going to leave the space because there's no real point in writing that out twice. What's the number that I want? 16. I take 8 divided by 2, that's 4. 4 squared is 16. I add 16 and subtract 16. Y equals, take the negative 1 outside the bracket, and then I can write it so it's x plus, remember, half of 8. And you got to make sure that when you divide the 8 by 2 or take the square root of 16, that gives you the same number. That's the whole point. That's how this works. Square root of 16, 4. 8 divided by 2, 4. But we made it work, so it'll never not work unless you pick the wrong value somehow, right? And then negative 16 plus 10 is minus 6. Yeah.
You forgot the square on the bracket.
Oh, thank you. Very good. We got that? Okay, let's do it. I want you to try this next one. What's my number that I add and subtract?
9.
9 plus 9 minus 9. So x squared minus 6x plus 9. Bring the minus 9 out. And the factored form of x squared minus 6x plus 9 is that x minus 3 squared. And then negative 9 plus 5 is minus 4. Is that what people got? Y equals x minus 3 all squared minus 4. And now I can actually graph this. So if I was looking at it like that, the original equation, x squared minus 6x plus 5, I wouldn't know what that looks like. But in vertex form, I do. So that's a shift to the right 3, 1, 2, 3, and down 4. And the a value is 1. A is 1. H is 3. K is negative 4. So it's shift down 4, right 3, and the shape is just normal. So over 1, up 1. Over 2, square it to go up 4. Over 3, square it to go up 9. So that should be right there, I think. Oops. And then I think in your practice, it wants you to identify some of the important information. So can you show the coordinates of the vertex? We could state the vertex. The vertex is positive 3, negative 4. The equation of the axis of symmetry, that's just like the vertex, right? So that's x equals 3. We can get the x-intercepts from this one. We can get the y-intercept. So we can get all this great information now that I've graphed it and when I completed the square. Does that make sense?